Hey guys, it's Miss Johnson here, and I am here to bring you our notes for right triangle trig. Up at the top of your notes sheet, so go ahead and find your notes sheet, pull it out if you haven't already. Up at the top of your notes sheet, the first example says the Americans with Disabilities Act provides regulations designed to make public buildings accessible to all. Under this act, the slope of an entrance ramp designed for those with mobility disabilities must not exceed the ratio of 1 to 12. This means that for every 12 units of horizontal run, the ramp can rise or fall no more than 1 unit. So the first thing that we're asked to find is the length of the ramp. So if I take a look at this ramp, I can assume that this ramp makes a right angle because it's going to be the horizontal and the vertical are perpendicular, and I have a right triangle here. So now, since I have a right triangle, I can find the missing side length, which is the length of the ramp, and in this case it's the hypotenuse. So using that to find the hypotenuse, that means I have 1 squared plus 12 squared is equal to x squared. 1 being the horizontal or the vertical rise and 12 being the horizontal run based on that ratio that the ADA requires us to use. So in this case, I can simplify and solve for x here. That's 1 plus 144 equaling x squared. That's 145 equaling x squared. So when I take the square root of that, I'm going to go ahead and just make this a decimal. I know yesterday we were doing simplified radicals, but in this case we're talking about an actual measurement. So I'm just going to make it a decimal, and that means I have 12.04 feet for the ramp. That's the length of my ramp there. So that's how long the ramp would be if I had a 1-foot rise and a 12-foot run. Now, the second question is finding the measure of angle A. So if I go back to that triangle that I have there, I'm looking for the measure of angle A, which happens to be this angle right here in the corner. Okay, it's going to be that one. Now, I have to use a trig function, which is what we're going to be talking about today, in order to find that angle. So using a trig function, I would have the opposite side, which is 1, and the adjacent side, which is 12. So my trig function would be tangent. And we're going to talk about where these trig functions come from and how we use them. So if I plug in the tangent of A equaling opposite, which is 1, over adjacent, which is 12, that's what my equation looks like. Now, I need to get that A by itself. That's what we do when we're solving any equation. We're trying to get the variable alone. So that means I need this to come over here, and I need the 1/12 to come over on that side. In order to do that, I use the inverse tangent function. So I have the tangent inverse of 1/12 equaling A. And you can plug all of these things into your calculator. You're going to use your calculator for all these trig functions. So if I plugged in the tangent inverse or the inverse tangent of 1/12, I get A equaling about 4.76 degrees, which we typically round to the nearest whole degree. So we'd have about 5 degrees here. So that means that's the angle that the ramp increases as you're going up or down the ramp. Okay. Now, those trig functions, there's 3 basic ones that we are familiar with. They are sine, cosine, and tangent. So this is how they are abbreviated. And you'll see that on your calculator, and you'll see that when we write them out using the notation, but that's what they stand for, sine, cosine, and tangent. And you guys talked about those trig functions in geometry. And then we also can use, in order to calculate these, we can use the clever little saying that we've all heard, SOHCAHTOA, which means sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. So let's just take a look and refresh our memory about those trig functions. If I use the triangle in the middle here that we can see, and I look at each of these trig functions, I'm looking at angle A. So that's my angle there, and I want the sine of A. The sine is opposite over hypotenuse. Opposite, I have the side length A, hypotenuse is C, so my sine is equal to A divided by C, or A over C. Cosine is adjacent over hypotenuse, which in this case would be B over C. And tangent is opposite over adjacent, so that would be A over B. Now we can also look at the reciprocal trig functions. If we take these trig functions, we all know that word reciprocal means flip upside down, flip the fraction, and those functions actually have names as well. So if I take the trig function and flip it upside down, starting with sine, the reciprocal function of sine is called cosecant. That's what that CSC stands for. So the cosecant of A would be the hypotenuse over opposite. Well, in this case, the hypotenuse is C and the opposite is A. So you can see that we just took this A over C and flipped it upside down, which again is what the word reciprocal means. The reciprocal function for cosine is secant. And again, so that means I'm taking cosine and flipping it upside down. So I'm looking at hypotenuse over adjacent. Hypotenuse is C, adjacent is B. And the reciprocal function of tangent is called cotangent. And the cotangent would be adjacent over opposite. The adjacent would be B, and the opposite would be A. So let's just practice finding those 6 trig functions in number 1. I need to fill in what those 6 trig functions are for the triangle that's given to me. So if I take a look at that triangle, I'm looking at angle theta. Now, if you've never seen this symbol before or you don't remember what it stands for, that's called theta. And you'll hear me refer to that a lot in the trig unit for sure. So I'm looking at angle theta. I want to find the sine of theta. And again, sine is opposite over hypotenuse. So opposite is 4, hypotenuse is 5. I'm looking at 4/5. The cosine of theta would be adjacent over hypotenuse, so that would be 3/5, because 3 is the adjacent side. Tangent of theta would be opposite over adjacent, that would be 4/3. Now those reciprocal functions, I'm just flipping them upside down. So that means the cosecant of theta is 5/4, because that's hypotenuse over opposite. Secant of theta is hypotenuse over adjacent, which would be 5/3, and the cotangent of theta would be adjacent over opposite, which is 3/4. So those are my 6 trig functions, and if I was trying to find them or identify them, that's what they would look like. Let's move over to the back and see if we can take a look at the next example. In number 2, it says, if the cosine of A is 2/5, find the value of the tangent of A. So I'm talking about cosine and tangent. Automatically, I know I'm looking at a right triangle. So the first thing that I'm going to do is draw myself a right triangle. Now, I always draw my right triangles the same way, so you're going to always see them looking like this. I put my right angle in the lower left-hand corner, and I usually put the angle that I'm looking at in the lower right-hand corner. So cosine of A is equal to 2/5. Cosine is the same thing as adjacent over hypotenuse. So I know that 2 is my adjacent and 5 is my hypotenuse. So adjacent is 2, hypotenuse is 5. Now I want the tangent of A, and tangent is equal to opposite over adjacent. Okay, well the adjacent side I know that it's 2, so I know my denominator is going to be 2, but the opposite side is missing. I don't have that side. This is a question mark here. I don't know what that is. Now, since this is a right triangle and I have 2 of the 3 sides, I can find it using the Pythagorean theorem. So I know one of the side lengths. I'm missing another side length, but I know the hypotenuse. I'm going to plug that into the Pythagorean theorem. I'm just going to call my missing side length x. So I have 2 squared plus x squared equals 5 squared. That's 4 plus x squared equals 25. And then I subtract the 4 over and I get x squared equals 21. Taking the square root, I have x is equal to the square root of 21. Now there's nothing I can do to simplify the square root of 21, so I'm just going to leave it as that because its prime factorization is 7 and 3 and there's nothing you can take out. So I have the square root of 21. Now, when I write out the tangent, because that's not my question, that's just what I needed that was missing in tangent, I'm looking for the tangent of A, or I'm sorry, the tangent of A, and I know that it's equal to opposite over adjacent. The opposite side is square root of 21, adjacent is 2, and that's my most simplified answer. There's no radical in the denominator that I have to fix, so that's my answer. I want you to go ahead and pause the video at this point and take a look at number 3 and see if you can complete that. And that's going to be the end of our video series for today. We'll finish up the other questions in class tomorrow. Thanks for watching. Don't forget to go back and take your Schoology quiz. Hop onto Schoology and find the basic trig notes quiz and answer the 3 questions given to you there. Have a great night, and I will see you tomorrow.